Okay. So for the last where we ended at number 8, but I wanted to do a little preview of number 7 and number 8 so it makes sense as we go through. So we're still on 3.4. If you remember from last time, I made some of you multiply x plus 1 quantity squared and you got your answer. And I made some of you multiply by x plus 1 quantity cubed and then you got your answer. And then I made some of you multiply by x plus 1 to the 4th and then you guys got your answer. Now, this Pascal's triangle is your shortcut. If you want to do it by hand or, old school way every single time, do it. Okay. But can you imagine when it gets to like the 6th, how annoying this thing is? Because to the 6th, you're literally multiplying. I mean, for me, I would multiply x cubed plus 3x squared plus 3x plus 1 times itself. So do you see how big this area model is going to be? It's going to be huge. So you keeping track of all those numbers makes me a little nervous. So Pascal is a mathematician and he came up with this whole triangle. And so this triangle helps us when we're expanding binomials like this. Okay. And so the way it works is you just have to figure out what row you're at. The 0th row is the very tippy top of your triangle. Then you have your to the 1st, to the 2nd, to the 3rd, to the 4th, to the 5th, and so on. So the way the triangle works is, hold on a second. The way the triangle works is you put ones on the edges. And then if you're trying to find the numbers in between those ones, like this number that goes in this box right here, you're just going to add the numbers that are above directly to the left and to the right. So this number would be 6. No worries. This number would be 15. This number would be 20. This number would be 15. This number would be 6. Does this triangle make sense? Because if you don't have access to this triangle, you're going to build the triangle, and building the triangle is not difficult as long as you remember how to add. So hold on, we're going to get to your question. So someone in the chat said, would it always be 1 or does it depend because it's x plus 1? So give me a second and I'll explain more of that in a second. So more to come. Okay. So if I wanted to fill out this very next row here, x plus 1 quantity to the 6th, I'd be using these as my coefficients. So it'd be like 1, 6, 20, 15, 20, 15, 6, 1. See how long it gets? Think about how annoying this box would be, right? Okay. So we're just going to continue. So some enterprising young mathematician noticed a connection between the coefficients of the terms of a polynomial and the number known of the patterns of Pascal's triangle. Put your answer for problem 7 into the table. So we already did that. Compare your answers to the numbers in Pascal's triangle. We did that. Triangle based and describe the relationship you see. We did that. It could save you some time on multiplying the higher power polynomials if we could use Pascal's triangle to get the coefficients. But first, we need to be able to construct our own Pascal's triangle and add rows when we need to. Look at your triangle and see if you can figure out how, okay, we did that. Now you can check Pascal's triangle by using x plus 1 to the 4th. We did that. Make sure that your answer from x plus 1 to the 4th, okay, we did that. Complete the next row of Pascal's triangle. I'm really literally reading this to you because I want to make sure that you all see that all of it's here. To find x plus 1 to the 5th, we did that. Okay, so here's Pascal's triangle. So this goes back to that person's question who asked a little bit ago, who said, hey, Ms. Johnson, what about this? What happens when, hold on a second, I just realized something. Give me a second. Okay, good. Okay, so the very next thing that's going to happen, ugh, the papers are over. Okay. The next thing that happens is now we're not dealing with a 1 right here. We're dealing with an A. Okay. So can you kind of look at this? I'll make it a tad bigger so you're not like, going what? Can you look at this side? This side is familiar to you. You understand. But what do you notice about what happens to the A in each of the terms in a row? So just look at one row. So look at this row with me. I need you to look at what is happening with A. What is happening with A? So can you put in the public chat what you noticed? What did you notice in terms of what is happening to A? What is happening to our A? A. But look at these A's here. What is happening? Yes, very, very good. That's exactly what I wanted you to know. So check it out in the public chat. If you guys all see, someone said, hey, Ms. Johnson, I noticed that the exponent is growing. Someone else says, yeah, they're growing. It's increasing. So when you guys are saying it's increasing, I'm going to push you kind of hard. I'm going to ask what is increasing. So if you're being a mathematician, one of the things that you'll notice is that mathematicians are pretty precise. They'll say, what is increasing? So someone who, the person who said the exponent is growing, that's exactly it. It's increasing doesn't help me. Like, what if I told you like, hey, it's over there? What would you all say? What is over where? Yeah, like what? I don't even know what you're talking about, Ms. Johnson, right? So we want to be as precise as possible. And that is a skill that you will get from being a mathematician. What does that mean, Ms. Johnson? So precision has to do with this. Like when I say something, you understand it exactly as I intended. Okay, so how many times have you ever gotten a text, sent a text, right? Gotten a text or sent a text, and the person that you got a text from didn't intend for you to understand it the way you received it, right? Like think about the word what. Like if you sent me a remind message and I wrote back what, no exclamation, no emojis, no nothing, that what could mean a lot of stuff, couldn't it? It could mean like what? It could be like, wait, what? It could mean like, huh? Like, do you see all the different ways? So that's not being precise. So when you are chatting with me, I need you to be as precise as possible. Very good. So exactly what you said was correct. I am going to snip that. I have to find my little snipping tool. Where do you, I have like three, there it goes. 3 screens and it always shows up wherever it wants to. So let me grab that. Oh my goodness, move over. And then yes, the exponent is growing or the exponent is increasing. Very good. So we want to be as precise as possible. Okay, so this is very important. This is very important. So we're going to be using this over and over again here. So it says, use Pascal's triangle method to find the standard form for x plus 2 quantity cubed, then check your answer by multiplying. So I'm pretty confident that you guys can multiply x plus 2 quantity cubed. What I would like you to practice right now is to practice using it here. So what I'm going to do, and we're going to do this together, we're going to do this step by step together, is I'm going to copy this row here and show you how I use it, okay? Okay. So what I'm going to do, let's scoot it over a little. Okay. So because I've been using this for a long time, I actually don't use this. I use this in my head. So I'm going to show you how I think about this. So the very first thing that I'm going to do is I am going to say x plus 2 cubed. Ooh, I copied the wrong row, y'all. How did I do that? Let's try again. Oh, I know why, because I said x plus 2 when I went to the squared. There you go. Copy. Hey, Ms. Johnson, she makes mistakes, right? Doesn't mean that I give up. It just means that I need to do better. All right, here we go. So the very first thing I'm going to do is I'm going to write x plus 2 cubed right underneath it. So x plus 2. So follow along with me. Okay. So in this case, who is x and who is a? Who is x and who is a? Yeah, a is 2. Very good. A is 2. Thank you. Thank you. And who is x? I know you guys are like, what, Ms. Johnson? X is X. Exactly. X is X and A is 2. That's important. Okay. The reason why that's important is because now you're going to build this. So in my brain, because I know the Pascal's triangle, I'm going to write it underneath here. I'm going to write 1, 3, 3, 1 first. My iPad keeps moving things on me. Hold on a second. Okay. So I'm going to start off with my exponents, and I'm just going to write 1 plus 3. Oops, I need to do more space. Sorry. Probably need more space because I write really big. Plus 3 plus 3 plus 1. Okay. So first I do my coefficients. Everybody okay with my coefficients? Then I start with my x's. X says start off with your highest power and then just take a power off every single one. This is that word incrementing. For those of you who want to be you want to code, incrementing is a huge thing. That's the way a program will crawl through like a whole data set of information. So you just increment things like by adding 1 or by subtracting 1, because all you're doing is say, okay, now go to the next row and look for it, or go to the next row and add or take the data from it, or whatever the case might be. Okay. So the next thing I'm going to do is my x's, and I'm just going to start with x, and I'm going to start with the highest power. The highest power is a third because that's what I'm taking it to the power of. So I'm going to go x cubed. Then I'm going to go x squared. Then I'm going to go x, and you can write a 1 right here. I'm going to write a 1 right there just so that you see how it's all going, how it's all playing out. So it's x third, x to the third, x squared, x to the first, and x to the 0. But guess what? I'm not going to write it because we all know that x to the 0 is just 1. Is everybody okay with this? Very good. All right. All right. So then I'm going to start with my A, and my A in this case is 2. Now, the guy in the back starts off with the smallest power and grows to the biggest power. See, no A, then A squared, then A cubed. So while X, the first guy, is starting with the strongest and then going down to the smallest, the guy in the back starts with the smallest, meaning A to the 0, which I'm not going to write. And then he starts appearing A squared, A cubed. So, but now I'm going to use 2. So this is 2 to the 0, which I'm not going to write because it's 1. Then this would be just times 2. So I'm going to write like a little times 2. And then I'm going to write times 2 squared. And then I'm going to write times 2 cubed. So this answers that person's question from earlier. Hey, Ms. Johnson, is it a 1? Are these ones here because we were dealing with x plus 1? And the answer is no, they will always be 1s. But when you evaluate it, do you see how we now take into account whatever value this is? Everybody okay with that? Okay. So then the last step is I'm just going to clean this up. So 1 times x cubed, well, that's just x cubed. Okay. 3 times x squared times 2 is plus 6x squared. Three times x times 2 squared, well, 2 squared is 4. 4 times 3 is 12. So this is plus 12x. And 1 times 2 cubed is 2 times 2 times 2 is 8. So this is just 8. So some of you are like, hey, but Ms. Johnson, your coefficients are no longer there. You're right, because we evaluated the A term. A to the 0, A to the first, A squared, and A cubed. So I like to ask you this question because some students, like, you instantly look at the most difficult thing, and I want you to start looking at what you can do. So can I ask a question? Are you okay with building your Pascal's triangle? Everyone's like, yeah, I could do that. Okay. Are you okay with starting X with the first term here with the highest power and taking 1 away from him every single time? X cubed, X squared, X to the nothing. Is that okay? All right. Are you also okay with starting with the second term in your binomial? Bi means 2, right? Bicycle, right? The second term and starting him off with the smallest power, which is 0, and then building him up to the first, to the second, and to the third. Are you all okay with that? Okay. And then multiplying, that's something that you guys have been doing since probably 8th grade in terms of exponents. So which part here is confusing? Is there anything here that I'm like, boom, this is the craziest part? Which is the craziest part for here? So pick something and say, yeah. So the confusing part here for me is keeping track of everybody, right? So I'm just going to say this. When my little ones were little, my daughter was 2, my son was 1, and my newborn baby was none. He was 9 years old. I used to say, I'd be like, I have a 3. What did I say? I said that wrong. I had a 3-year-old, a 1-year-old, and a 9-year-old. I was constantly, as they were growing, counting to 3. Constantly. 1, 2, 3. Okay, all 3 of them. When we were at the park, 1, 2, 3. Okay, good. I was constantly keeping track of where they were and where they are supposed to be, right? So that's what you're doing here. You're constantly keeping track of who and where. And that's why I built it the way I did. And I should have used a different color because those green and the blue kind of look the same. So I first laid down my coefficients, which is my 1, 3, 3, 1. 1, 3, 3, 1. And then I built in my first term with the most powerful x cubed, x squared, and then he got smaller, x to the first, and then nothing, right? So he's like, kind of like fading out. While this guy, the second term, he's fading in, right? Nothing, 2 squared, 2 cubed. So there's this like I don't want to say opposite because that means something different in math, but there's this like symmetrical thing that's happening between your first term and your second term, where your first term starts off really, really strong. Yeah. And then he is no longer. A way that I check my answers just so that you're here is because this is a 3, it's to the third. Your 2 terms, x and your 2, your x and your a, their exponent should always add up to 3. So check it out. This is 3 plus nothing. That's 3. This is 1 plus 2. That's 3. That's 2 plus 1. That's 3. That's 3. And that makes sense because as one is growing, the other one is fading out, right? So lots of little ways for you to check here. So then they told you to check your answer by multiplying. So some of you are so, I don't know, you've bought into my like math is the best way for, or the best way for you to increase your grade in this class is by checking every single answer. So once you're done with this, you're going to go through and you're actually going to multiply out old school, maybe like this, using a box and making sure that your answer is correct. Okay. So there goes that. Any questions on this? Okay. So what we're doing here is this is called expanding because it's almost like a rubber band. Oh, how would I multiply this with a box? Two at a time, right? Let me finish this expanding and then I'll show you how to check it. So this is called expanding. Like, can you think about a rubber band? It's just sitting on your table and then you put your fingers in it and you stretch it out. This is called expanding the rubber band. Do you see how long this expression is now compared to this little guy? Someone asked, is on the quiz, will there be a question where you have to use the triangle? I am not a huge fan of you have to do it this way. But I am a fan of make sure you know multiple ways, that way you can check your answer, right? Okay, so let's check our answer really quick, just so that we're all on the same page. Ms. Johnson, how would you do this by hand? So I would do this first by multiplying out x plus 2 times x plus 2, x plus 2 times x plus 2, right? Just like this. So go ahead and actually, I'm going to have you do this really quick. So pause. I'm going to pause you and multiply this out. Give me an answer right here. I'm going to give you like a minute and a half. All right, so you all did this. So I'm going to fill this in super quick. So you all did this. And so you got x squared plus 2x plus 4, right? And so again, how do you do this? You just multiply this term by this term, and then you put it in that like corresponding box, right? So then I get this, and I get x squared plus 4x plus 4, right? So this is two of them, 1, 2. If I wanted to cube it, then I'd have to multiply it one more time by 3. So I'm going to multiply this one more time by x plus 2. All right, so now that's your work. Go ahead and multiply this out and see what we get. Now your hope is, now while I'm talking, you're writing. My hope is that this answer here is the same as this answer here. Okay. That is your hope. Your hope is that those two match exactly, right? And if they don't, it means you did something wrong. If they don't, it means you did something wrong. And then you could always go to Desmos to check the graphs of them. Remember how we were doing before? You'd plug this side in, you'd plug this side in as another, and they should overlap. If they don't overlap, you made a mistake. Okay. So I'm going to multiply out now because I think you guys had enough time. And I'll go a little slower. So x times x squared is x cubed. X times 4x is 4x squared. X times 4 is 4x. X squared times 2, that's 2x squareds. 2 times 4x is 8x. And 2 times 4 is 8. Okay, I'm going to make sure that I didn't make any mistakes because Ms. Johnson, pretty classic. X cubed, 4x squared, 4x, 2x squared, 8x, and 8. Yeah. Okay, so now I'm going to add them all together. And I get x cubed plus 6x squared plus 12x plus 8. And so, yay, I got the same answer, right? This looks the same as this. And again, if you wanted to, you can also check on Desmos, right? So here's this, but I do need to see your work. Don't think that you can just grab the answers on Desmos. Actually, you couldn't grab this answer on Desmos. So here, you'd plug this in, and you'd see if those two graphs would overlap. Okay. So now that that's done, the only thing left to do is for you to practice. Now, I will caution you. I'm going to caution you. Which one of these do you think is going to give you the most problems? Which one of these? Yeah, this guy right here. Okay. So this guy right here, when I'm writing him here, I'm writing him in parentheses with that negative. So that's actually the one that we're going to start with right now because we already did most of the work. You're going to see how this compares to this. So this is the one that I want you to start off with. I am going to push you right now because we're in practice, not on the test. I want you to practice using this one, this method here, using the Pascal's triangle. Okay, go ahead and try this one. Okay, so now that you're doing this again, I'm going to use the same kind of information here, and I'm going to build one at a time. And so when I do this, when I'm working on this one, yes, you can actually do it this way. If you prefer this way, then you should do it that way. This is just like one of those shortcuts that is pretty cool in math that if you remember how to do it, then you should do it. So the very first thing that I do is I write out my coefficients. So I'm going to pull these because it's still a cube. So it's going to be 1, 3, 3, 1. So I'm going to go 1, leave some space, plus 3, leave some space, plus 3, leave some space, plus 1. So I'll like leave a lot of space so I can actually show you what I'm doing. The next thing I'm going to do is I'm going to take the first term and like start it at the top and make it go down a step every single time, right? So then I'm going to go start with x, and I'm going to start with what power? To what power should I start x off with? To what power should I start x off with? Yeah, it's going to be 3, right? I'm going to use a 3. Ms. Johnson, why 3? Because it told me to start with x cubed, right? So this is going to be x cubed. This is going to be x squared. This is going to be x, and then that's going to have no x's, right? And then I'm going to do this. Now, this is where the minus sign matters, okay? Now, you could either figure this out, or you could just do what I'm doing here. So what I'm going to do is I am going to actually start it off with the smallest power, and I'm going to write it in parentheses. So -2 to the 0th. Why did I put it there? Sorry, I need to move this over. Sorry. So I'm gonna write all of these in. Oops, sorry. I'm gonna write all of my -2s out. So you all see this is, oh, Ms. Johnson's using parentheses here. Yeah, I'm using parentheses here specifically because I need to make sure that my negative influences or uses its, like I'm not just forgetting about it. Ms. Johnson, well, how come we didn't have to do it over here? Because it was a plus, and a positive times a positive, or a positive times a positive will always give me a positive, right? So then I'm going to start with my powers. So my power here will start off with 0, then we'll move to 1, then we'll move to 2, then we'll move to 3. Okay, so you could see there's gonna be some influence, not on the numbers. So it's gonna say x cubed, it's gonna say 6x squared, it's gonna say 12x, it's gonna say 8, but on the operations in between them, and then you'll see the pattern. And you'll, if you think about it, it literally makes sense. Okay. Okay. So then, so this to the 0, that's just going to give me 1. So my final answer is just going to be x cubed right here. Plus. Now this guy, -2 to the first is -2 times 3 would be -6x squared. So this needs to say -6x squared, which now you see, oh, that is what is different. Now, some of you are coming up with your own conjectures on why it's different. Do that. Come up with a conjecture of why it's different. And will that influence this term? And will that influence this term, kind of thing. So you always want to like have these, I mean, you don't have to, but it's good practice mathematically and thinking wise and problem solving wise for you to come up with these conjectures. I wonder if it's because of this. So then take that and then test it on these two terms. Okay, so what about this one? What happens here? What is this term going to simplify to? Yeah, very good. So some people are putting some stuff in the chat. Very, very good. Yeah. So I'm going to slow it down for you. -2 squared is +4. +4 times 3x would be 12x. Okay. And then your last term, because you guys already did this, you were like, oh, yeah, this makes sense. It's -8. Anybody see any patterns? Now the x cubed, the 6x squared, the 12x, and the 8, those match. My signs, my operations in between them do not match, right? They don't match. So what is the pattern that you see? Anybody see the pattern? What pattern do you see? What pattern do you see here? With my exponents, specifically with my exponents. That's what I'm interested in. Anybody see it? Yeah, they're like alternating. Not the exponents. I'm talking about the operations, the minus and the plus. They're alternating, right? minus, plus, minus. Anybody have any like conjecture? Anybody have any conjectures on why they would alternate? A conjecture is just you making like, I think it's because of this, Miss Johnson. But it's not a guess. People say, oh, it's a guess. No, it's not. It's not a guess because a guess means that you're completely, you have no clue about any of the information. Here you have clues. They told you. Yeah, it has to do with the exponent. Yeah, so you guys are all kind of saying it together, and I have all of your chats. So some of you are privately chatting me, and it has to do with the fact that -2 to the first is 1 -2, but -2 to the second is -2 times -2. And what do you know about a negative and a negative? What do you know about a negative and a negative? Yeah. So like if there's an even number of negatives, your answer will be positive. If there's an odd number of negatives, it'll be negative. And because our numbers alternate between even and odd, that's why they alternate. Very awesome. Okay. I know that this was like one of those lessons that like take a while, but I want you to convince yourself that there's nothing here that is like, this is hurting my brain. Keeping track of everything and organizing, that's why I write everything first. I laid down coefficients. Then I laid down my first term with the powerfulest, that's not a word, but it's okay, powerfulest exponent, and then like took them down second to the first, none. And then my second term to the 0 to the first to the second to the third. So I know there's a lot of stuff that you have to keep track of. And the phrase that I really, really like is math may not always be easy, but it should always make sense. And because we have this other way here, it makes sense. So when I'm asking you about patterns, those all make sense. So, all right, that is that. Really good job.